The P0007 code indicates a high voltage condition in the fuel shutoff valve A control circuit. This valve, typically a solenoid in diesel engines, regulates fuel flow to prevent engine runaway. A high reading means the circuit voltage exceeds the expected threshold when the valve is off. If the voltage exceeds 0.5 volts when off, you may have a problem. Several factors can trigger the P0007 code. These include wiring shorts to power, corroded connectors, a faulty fuel shutoff valve solenoid, or in rare cases, malfunctions within the engine control module. Rodent damage to wiring harnesses is a common culprit, leading to shorts. Identifying the root cause is crucial for effective repair. The presence of a P007 code can manifest in various ways. You might experience engine no-start conditions, stalling, reduced engine power, or the illumination of the check engine light. In severe cases, the fuel injection system might be locked out, mimicking a security system fault. Diagnosing P0007 requires a systematic approach. Begin with a visual inspection of wiring and connectors for any visible damage, corrosion, or loose connections that could cause a high voltage condition. Next, use a multimeter to test continuity, resistance, and voltage at the fuel shutoff valve connector. The solenoid resistance should typically measure between 10 and 50 ohms. Compare your readings against manufacturer specifications. For example, GM vehicles allow a maximum of 2.8 volts in the off state. Exceeding this indicates a high circuit condition. Finally, scan for live data using an OBD2 scanner to confirm the high voltage condition in real time and rule out intermittent issues. Repairing a P0007 fault involves isolating the issue. Start with visual inspections and component testing. Replacement of the FSV solenoid typically costs between $50 and $200, with labor adding an additional $100 to $300. After any repair, clear the code and conduct a test drive to verify the fix. Real-world cases demonstrate how P0007 manifests in different vehicles. These examples show common causes and successful resolutions. In a 2018 Ford F-250, rodent damage created a short circuit in the wiring harness, causing P0007. The owner reported engine stalling and check engine light illumination. Visual inspection showed melted wiring. Replacing the harness and solenoid fixed the problem quickly and cost-effectively. A Chevrolet Silverado HD fleet with 50 trucks experienced P0007 due to faulty OEM solenoids from a 2019 batch. Symptoms included reduced power and check engine light. A class action settlement resulted in free replacements for 10,000 units, with owners reporting 5 to 7% fuel efficiency improvements. In a Ram 2500, an intermittent P007 was caused by a loose connector, resulting in sporadic engine stalling. Using an oscilloscope, technicians captured voltage spikes. Replacing the $50 connector resolved the problem without needing ECM replacement, emphasizing thorough diagnostics. Experts recommend proactive ECM scanning to differentiate P0007 from similar codes like P001 injector circuit faults. P0007 accounts for 2.5% of diesel repairs, with higher incidence in colder climates due to corrosion on wiring and connectors. Mechanics advocate using OEM-approved parts to avoid warranty issues and ensure a reliable fix. Looking ahead, the prevalence of P007 is expected to decline as diesel vehicles transition to electrification and hybrid technologies. This shift reduces reliance on traditional fuel shutoff systems. AI-driven predictive maintenance systems may help prevent P007 by detecting wiring issues early before they cause circuit faults. However, in commercial fleets with high mileage, the code will likely continue to appear due to aging vehicle components. Experts predict a 20 to 30% drop in P0007 diagnoses by 2030 as technology advances, though fleet vehicles remain vulnerable.